Welcome to the Web of Tomorrow. I'm Adam Harris. Today I'm talking with Andrew Jensen. He is a software engineer at Domo, where I work, and we're going to talk about the Internet of Things and software/hardware project he's worked on in the past, and a little bit about how to get started with hardware and software. Hey Andrew, how's it going?
Hey, good. How are you doing?
Good. Welcome to the show.
Well, thanks very much. It's good to be here.
So we're going to talk about hardware and software stuff. I know you've done some of that. So we've worked for like a year or so together at Domo. And I'm on a different team now, and you're on a different team too, I guess, right?
Yeah. I guess we've both been kind of shuffled around recently.
Yeah, but we've had some I think cool conversations about this type of stuff. So what's like your background in hardware stuff?
So my background in hardware stuff is really mostly as a hobbyist. I'm a software guy too, and I've been doing web for a long time. But in terms of hardware, I'm a hobbyist, and so is my dad. He kind of got me into it. Let's see, he's been doing it for a long time, and in high school, I guess he showed me a few books and showed me some circuits that he had designed for fun on breadboards and perf board, and I didn't think much of it at the time. I had a brother or two that were pretty interested in it, and they spent some time on it, but it wasn't until really kind of the last year or two that I've really started into doing a lot more hardware projects in my free time.
So that's cool. You've got like brothers and your dad that are also programmers?
Yeah, so I have I'm the oldest of four boys, and it's great because we're all nerds. So my dad is a software engineer as well, and tinkers with hardware in his free time. I've got a brother that studied bioinformatics, and so he's crazy because he knows everything from programming to the human genome to biology. Another brother that's studying accounting, but he tried some things, and then my youngest brother. He's still in high school, but I'm trying to groom him to be an electrical engineer. We'll see what happens.
Oh, cool. That sounds pretty fun. So let's start off with what is Internet of Things? That's one of the things we want to talk about is Internet of Things.
Yeah. So I think it's worth saying at first that the phrase Internet of Things is a little bit of a buzzword.
Yep.
It sounds fancier than maybe it really is, but the concept is still very cool. We call it the Internet of Things because phase one of the internet was a bunch of computers plugged in together to the internet, and it was big mainframes, and then it was personal computers. Now it's laptops and smartphones. But I mean, those are like dedicated computing devices that we use, and they all talk to each other over the internet. And whenever we had other devices plugged in, those were peripherals. Like we would plug in some extra thing to our computer to the internet. Whereas the Internet of Things is this kind of second wave of devices that are connected directly to the internet rather than being peripherals for computers. So that's where we're seeing things like thermostats and cameras and door locks and all kinds of things that have direct internet connectivity.
Yeah, that's pretty cool because we used to have we've had cameras on our computers for a long time, but they were always plugged into a computer that was connected to the internet, and now we have cameras that just connect directly to the internet themselves.
Right.
Speaking of peripherals, do you remember this thing that was like shaped like a cat? So like you had a mouse already, so they made this other thing that was a cat, but you would use it to like scan barcodes.
You would scan barcodes with it?
Yeah.
No, I don't think I remember that. I'm gonna have to go Google that.
Yeah, it was weird.
I remember this like handheld game that I got one time. It was called Skannerz with a Z, and it was like this like Tamagotchi style thing. This little LCD display was on it,
Yeah.
and you would scan barcodes at the store,
Oh.
and then the barcodes would like turn into monsters, and you could battle with it. It's so cool.
So it actually had very little to do with the actual barcode.
Yeah, the barcode was really just like a hash code that decided which monster it was.
Yeah.
Great game though.
Cool. So, what kind of things have you built?
So I've done a couple of kind of fun side projects. Uh, so one of them that I've kind of started, but I want to spend some more time on, is called Arcade Commander. And Arcade Commander is kind of a combination of a command line interface and and then some buttons that
Okay.
are plugged in, really as a peripheral to the computer. It turns out you can find really cool arcade buttons on a lot of different websites. Sparkfun.com is a good one. Adafruit.com is a good one. And so you can actually buy the same kind of buttons that are in like arcade games that you would find in an arcade.
Awesome.
And so these giant red and blue buttons that you can mash really hard with your thumb. And so what I did in this project is I took two buttons, wired them up to an Arduino, and then the Arduino connects to my computer through USB, and it sends serial messages back and forth when I press those buttons. And then what I do is I've got a CLI tool that starts listening for those serial messages, and then it can relay to kind of whatever I want it to be. So, for example, I can press the button and run my unit tests in one of my terminal tabs. I can press the button and deploy my code, or git push, or that kind of thing.
Yeah.
Like if I can run it as a terminal command, I can do it from a giant arcade button, which is pretty
Awesome.
satisfying.
So do you have to have the terminal open already, or can you be in Chrome and just push the button?
No, you have to have the terminal running.
Okay. Cool. So what kind of plans do you have for this?
I think it would be really cool in the future to build a whole kind of relay system for this thing, so that messages come in and you have a server that's running in your terminal that picks up those messages, and then you can register new things that respond to those messages. And so, for example, if I want to do something in Chrome, then Chrome would connect onto that server, and then I could use my arcade buttons to step through my JavaScript debugger in the
Yeah.
browser. Or I could, I don't know, I could like add this page to my favorites, or save it on Pocket or Evernote or something like that.
Yeah, that would be cool. So what kind of hardware exactly did you use to build this besides the buttons?
Sure. So I used those arcade buttons, but the microcontroller I used, it wasn't actually a name brand Arduino microcontroller. It was actually something called Teensy. And Teensy is this other controller made by somebody else. It works with all of the Arduino things, like it works with their IDE and their tool chain for putting code onto the device. But it's got a couple of other really cool features. For example, right out of the box, a Teensy microcontroller can work as a couple different kinds of devices. Like it can work as HID, which is human interface device, and that's the same protocol that a mouse or a keyboard or a joystick uses.
Okay.
So you can just choose that in a context menu, and save it to your Teensy, and for all your computer knows, you have an extra keyboard plugged in.
Okay.
So a lot of these kind of indie mechanical keyboard companies will actually build using Teensy microcontrollers.
Yeah, I've got an Ergodox that's made with a Teensy
Okay, yeah.
Ergodox keyboard.
Do you happen to know what kind of Teensy it is?
No, I don't. I didn't know there's different kinds.
Yeah, so not quite as many kinds as the Arduino. There are probably a dozen or more kinds of Arduino dev boards, and they're all a little different from each other. The Teensy, there are kind of two main types. The main Teensy microcontroller is really along a single like versioning pattern. So right now it's the Teensy. Oh, let me double check. Yeah, it's on the 3.x version right now. And they just released the 3.5 and the 3.6, which are really cool. And they're really pretty powerful machines. And then there's the Teensy LC. And the Teensy LC is a lot cheaper, but it doesn't have as much processing power. It doesn't. It's got a slower CPU, and it doesn't have as many GPIO pins as well.
Okay.
But for your small projects like Arcade Commander, Teensy LC works really well.
So, what else have you worked on?
So one other project that I've kind of started, it is more of an IoT project, and it was actually teaming up with my dad. So fun, father-son activity, built some family unity. We're calling it MIDI Techno lights, which is great. So MIDI, you might have heard of MIDI before, but it's a protocol that musical instruments use. And so synthesizers and drum machines and controllers, they all speak this common protocol of MIDI. And there are these round cables with 5 pins that plug into all your devices, and they can send MIDI messages back and forth. And you can also do MIDI over USB, because really MIDI is just a way of sending messages. It's just a protocol.
Yeah. I wasn't even aware that it was a type of cable. But yeah, I see a picture of it, and it looks a lot like is it a standard microphone cable, or is it a little different? I think a standard microphone cable only has 3 prongs, right?
Yeah, that's right.
Okay.
So this kind of cable is called a DIN cable, and it's got 5. And there are even some other types of devices that use DIN cables, like what is it called, DMX lighting. Like when you see the fancy lights on stage for performances, that usually is using the same kind of cables, and they use kind of a similar message format. So MIDI, since it's this format that's really easy to send messages back and forth between musical instruments, it's a good protocol to use when you're performing music. But then you can turn it into other protocols. And so I play electronic music. And I wanted to have a way to control lights from my music, so that when the music changes, maybe it gets louder or softer, or the tone changes, so it's buzzier versus more muffled, or all those kinds of things. I wanted the lights to respond to that. And so what I did is I wrote a script in Node that would take MIDI messages from my music program, Ableton Live. It would take those MIDI messages, and then it would reconvert them into API calls, and it would send those API calls to a Philips Hue base station. And so I could change the color of Philips Hue bulbs from my music program.
Cool. So how many bulbs can it control?
Really, it can control as many as you can pair to a base station.
Are they all doing different things, or are they all doing the same thing?
They could all do different things, really.
Okay. Cool. So right now, is it just with Philips Hue, or can you just like plug it into something else?
For now, it's just Philips Hue.
Cool.
But yeah, what we built so far is kind of a base library, so that MIDI comes in, and then there's an API, or we wrote an adapter around the Philips Hue API, so that you can write some code on top of that to decide what your specific song does, or what you want to do with the lights.
So it has like different options?
Yeah. And then I think we could grow that so that you could swap out Philips Hue for some other kind of light bulbs, or you could use one of those LED strips that are becoming really popular right now.
Cool. What else?
Let's see. So another fun project that I did it also had to do with the MIDI protocol. I'm calling it MIDI clock triggers.
Okay.
And it's not clock triggers in the musical sense where there's a metronome that's running. It literally has to do with the clock, like the time of day. And this goes back to a time when I was living in this student apartment. It was a very cheap, really lousy apartment. And I was up on the 3rd floor with my friends, and we were in apartment number 17. Okay. And we said, hey, we should like throw a dance party for like all of our friends in the neighborhood. And so, that's fun. People do that. but we thought, well, it's not gimmicky enough. Yeah, like we need to find some other funny things to do with this. And so I said, hey, we're in apartment number 17. What if we had a dance party that was exactly 17 minutes long? And so, and so we wrote some software so that we could do that.
Naturally, that's what you do when you want to throw a party.
Yeah.
Write some software.
It's a good party trick, like knowing how to program computers. So yeah, and the reason that's fun is because when you go to some dance party, you don't want to be there for an hour or 2 hours. You get tired.
Yeah.
Like 20 or 30 minutes is a great amount of time, and 17 is. 17 is just so significant that we had to use 17 minutes as the cutoff.
Okay. So are you using this for a company holiday party tonight?
Yeah, we could throw an after party up in Salt Lake.
Yeah.
Be kind of fun.
So, okay, what does it do exactly with it?
Yeah.
17 minutes? It's just play music for 17 minutes?
No, so it's another adapter, kind of like the MIDI Techno lights were. So the MIDI Techno lights were MIDI comes in and then HTTP requests come out.
Okay.
This is actually the opposite, where the time of day comes in and then MIDI messages go out. And so that way I could use my same audio program, Ableton Live, and when the clock struck 10 o'clock sharp, then that script would trigger a MIDI message that would go to my music program, and it would press play on the first track, and then I could start live DJing from there. And so that way, that script was synchronized perfectly to my computer, which was synchronized to the atomic clock. And so I knew with a fairly low tolerance in terms of time that it was exactly 10 p.m. when it started.
Yeah.
And then when it was time to stop at exactly 10:17 p.m., then the clock triggered that MIDI message, and the MIDI message went to Ableton Live, and Ableton Live muted the master track. So all of a sudden, it was this big song was building up and building up and building up, and the bass was going to drop or whatever, and then the audio just cut out right at 10:17.
Wow. Then everyone went home, or?
Yeah, that was it. Everybody was kind of confused for just a second, and then they realized that Andrew and his friends weren't kidding when they said they were going to do an exactly 17-minute long dance party.
That's funny. Cool. Yeah, I've really been meaning to get more into electronics, so it's cool to see what kind of things people have been working on.
Yeah, absolutely.
I've got a Raspberry Pi, I've got an Arduino, and I've got a Particle.io Photon.
Oh, yeah.
The Photon is really cool because it connects to the internet over Wi-Fi. And then they also sell one that can connect with 3G.
Oh, that's really cool.
Anything else you want to say?
Sure. So we've talked a little bit about different kinds of development boards, right? We've talked about Arduino, Teensy is a close relative. We talked about Photon and a little bit about Raspberry Pi. I think there are a lot of other things that kind of go into working on hardware. There's just so much. I mean, it's an entire field, right? And most of us that are interested in IoT as hobbyists come from a software background, and so we're less likely to know things about resistors and capacitors and transistors and op amps and all that.
Yeah.
And so I think it can be kind of overwhelming at first to know where to get started once you go past just a single microcontroller with some buttons. But I think some of the really great places where you can learn are the blogs from Sparkfun and Adafruit. Those are both really good.
Okay.
Often you can find really good tutorials on Instructables. That's a really cool website where people will post projects that they've built, and they'll walk you through step by step how to actually recreate what they've done.
Okay.
And there are also plenty of really good YouTube channels. One of my favorites, since I do music, is this channel called Notes and Volts. And there's this guy that he teaches you how to build a MIDI controller. So they're a bunch of buttons and knobs, and then those will send MIDI messages into your music program so that you can use it to control your music. And he actually walks through some of the circuitry beneath it. So rather than just, oh, okay, you need to buy these things, solder them together like this, he kind of explains, here's why you need this. And it's really cool. He does a really good job.
Awesome. Yeah, I've been going through a book called Make Electronics, which takes you from the very basics all the way through building your own circuits and soldering onto a board and stuff like that.
Oh, that's really cool. And Make is a really good publisher. Like they find some really good authors, and their books tend to be really high quality.
Yeah, and they even sell kits that give you the exact parts you need to build the stuff in the book.
Yeah, and that is an awesome way to get started with some more in-depth hardware things. Because buying components online can feel a little overwhelming when you come to like a manufacturer or a reseller like DigiKey or Mouser. Like you can buy anything on there, but it's kind of scary when you look at their tables.
Oh yeah,
there's just so much. So yeah, kits are a really good way to go if you want to get started.
Yeah, I've liked it so far. Yeah, thanks for coming on the show.
Well, thanks very much. This was awesome.